All right. So today we're looking at filling in the whole unit circle. We're going to be filling in, or at least the critical pieces of it. And so as you take a look at that picture that you have, we're going to start by filling in that first quadrant together. The first quadrant is the upper right-hand corner. The first thing we're going to do there is get a nice easy angle. What is the measure of this angle that you see highlighted up there? It's what?
Zero.
It's 0, yeah. It's going straight to the right. Straight to the right is... Now, you might also be thinking, well, what about 360? Couldn't it be 360? Yes, 0 and 360 are at the same spot, but when we label them, we just choose to use the 0, since 360 is like after having gone around one full time. We start at 0, so I use the 0 there. And then we're going to see how we can actually fill in the coordinates of the point that go with it. Now, to fill in the coordinates, notice it's an x-coordinate and a y-coordinate. What do we use to find the x-coordinate? We saw this yesterday.
Cosine?
Yep, cosine. So we're going to be doing cosine of the 0 degrees to get my x-coordinate. And what about getting the y-coordinate? What do we use for that?
Sine.
We use sine. Yep. And so in order to find the coordinates of this point, I'm going to be doing cosine of 0 and sine of 0, which yes, we can do on our calculator, although you actually can do it without your calculator too. Because, like, this x-coordinate here, remember this is a unit circle, so that means that this point in the center of my circle, that's the point 0, 0. And what's the radius of the unit circle?
1.
1, yep, that's why it's called a unit circle, because the radius is 1 unit. So notice, in order to get to this point right here, I have to go straight over to the right 1 unit. Well, doesn't that mean my x-coordinate is going to be 1? And the y-coordinate. Notice I'm not going up at all at that point. I'm just going over to the right but not up at all. That means that my y-coordinate should be 0. So we get 1 and 0 for our coordinates there. Go ahead and fill those in, 1 and 0 for that first point at 0. And notice we could do that first one without a calculator, although that's not always going to be true as we go through these. In fact, to get these other ones, we're going to need to fill in the angles first, because we need to know what the angles are before we can find those values, because we will be using a calculator for them. So the next one for us to get, let's find that angle when we go straight up. That angle, yes, it is 90 degrees.
90 degrees.
So we're at 90 degrees there. Next up, what about this one? Well, you'll notice that it's exactly halfway between 0 and 90.
45.
Okay, so half of 90 then is 45. So that's going to be 45 degrees. But then what about these other two? How can we know those? Well, those are actually breaking our circle up into even pieces. Now, when I do that, how many pieces am I breaking it up into? Well, you notice there's one here. Use a different color to make them easier to see where the different pieces are. There's another piece, and there's another piece here. So my 90 degrees was broken up into 3 pieces. So how big is each piece?
30.
Yep, 30. Therefore, that angle right there, that's going to be 30 degrees. Because it is 1/3 of the 90. And the same idea then goes for this piece. Because I went 30 degrees to get here, I go another 30 to get there. So that angle there has to be 60 degrees. Now, before we go too much deeper, as you look around the rest of your circle, the rest of the angles are all going to follow the same pattern. Just to help you see what that pattern is. Notice I went 30 degrees, obviously, from 0 to 30, right? But then to go from 30 to 45, I went 15 degrees. Then I went another 15 degrees, and then I went 30 degrees. That same thing is going to happen as we go around the rest of it. So for instance, as I keep going over here, it's going to be 30, 15, 15, 30, 30, and so on and so forth all the way around. So we can know that pattern is going to hold up once we get to actually filling in the rest of those angles. But before we get into filling those in, we're going to find the rest of these coordinates up in the first quadrant. So I need the x-coordinate for 30 degrees. Again, what am I going to use to find the x-coordinate? Is that sine or cosine?
Cosine.
X-coordinate? Yep, it is cosine. So I'm going to have to do cosine of 30 degrees. Now it's calculator time. On your calculator, please calculate cosine of 30 degrees. You should get an x-coordinate here of 0.87. Notice I'm rounding to 2 decimals because we were told to round to the nearest hundredth. Alright, so we got 0.87 for our x-coordinate. Now I need my y-coordinate. Okay, what do we use to find y?
Sine.
Sine. Every time. It is sine to find the y-coordinate. So we're going to do sine of 30. Although for this one, yeah, normally we'd use a calculator, but this one, actually I hope you don't quite need the calculator yet because I've given you this value a few times. This is the value I normally have you use to test your calculator. If your calculator is in degrees, you should find that sine of 30 gives you 0.5. Exactly 0.5. That's not rounded or anything like that. Next up, let's go up to the x-coordinate for 45 degrees. Okay, is it sine or cosine for the x?
Cosine.
It is cosine, so we're going to do cosine of 45. You should find that when we do that, we get about 0.71.
Wait a minute. Why do you?
Now, having done those, take a moment, do these other 3 calculations now to find those other coordinates to make sure that you got the idea about how we find them and to see some interesting things that start happening along the way. All right, and then when you do those calculations, these are the numbers you end up getting. Now, some interesting things start popping out as you take a look at these numbers. The first one that normally jumps out is this. Our y value was exactly the same as our x value for 45 degrees. And actually, that's what we'd expect to happen. Because 45 degrees is where you're actually getting a triangle that is the same width as it is high. Because a 45 degree angle and a 90 degree angle mean the other angle also has to be 45 degrees. It happens to be isosceles. And so because of that, it'll always be the same. So anytime you're getting one of these 45 degree angles, and there's a number of them as you go around, just at different intervals so they have different numbers on them, you will see that your x and y coordinates should be basically the same. We'll have to pay attention to the positive negative part of it though. All right, and then at 60 degrees, you'll notice those are familiar numbers again as well, right? You notice at 60 degrees, these two numbers are the same as what we had at 30, except their positions are swapped. That's because if this triangle over here, if that's 60 degrees, that means the angle up here is 30 degrees. And when we do it for the other one, the 30 degree triangle, if this is 30, that means this one has to be 60. Notice it's the same triangle dimensions, the same angles. Because they're the same angles, we end up getting the same side lengths. It's just a matter of which one is the x and which one is the y in that case. Now, those are just some patterns that we see even just in this first quadrant. But we're going to be expanding this out quite a bit. We have a whole unit circle still to fill in. And in terms of all of this, we need to find all of those remaining values. And then when all is said and done, these are the values we end up finding for all of those missing pieces. Now take a moment, check the values you calculated, and then fill in the remaining ones so that you have a complete picture, because we're going to be using this picture in our next step for what we're doing today. And then we'll also be talking about some of the cool patterns that we can see in this circle picture as well before we get to that. All right, now a few patterns that I want you seeing. First of all, we already saw some just in the first quadrant. Like remember the 30 and the 60? Same numbers, just they switch places. Take a look at how that shows up in the other quadrants as well. So like here in the second quadrant, basically the same numbers switching place, but you notice one of them is positive, one of them is negative now, and the negative doesn't necessarily switch with it. But that same pattern does hold up where we're switching the order of the 0.5 and the 0.87 between those two. And in all of them, just like we had with the 45, you'll notice those where the two numbers are the same. Just having to, again, look out for the positives and negatives. So what about those positives and negatives? Do you see the pattern when it comes to positives and negatives? Because remember that as we take a look at this picture, the center is the origin. The center is 0, 0, right? And if the center is where 0, 0 is, if I'm trying to find the coordinates of a point, right and up is considered positive. Left and down is negative. So anytime I'm going to the left, notice my x-coordinate is negative. So all of these x-coordinates out here are negative because we're going to the left of the origin. And all of our y values, well, notice where they're negative. We would expect our y-coordinates to be negative when we're going below the origin. And that's what we can see because we can see our y values being negative down here. And so the signs are all just based on the fact that we centered the whole picture right there at the center of the circle. And then one other interesting set of things that you can observe, because you can actually get to know this pretty quickly, and a lot of people actually memorize this picture in a fairly short time just because it gives them that nice reference, is you'll notice like between these 2 points right here, 60 degrees and 120 degrees. You notice those 2 points actually have the exact same y value, which should kind of make sense because they're at the same height, right? But then you'll notice then the x values, well, over here I'm going 0.5 to the right, over here I go 0.5 to the left. We go the same distance away. And that is in fact true for all of these that have the same height. You'll notice that pattern between the points. And so there's these connections between points that are across from each other, or if we want to go into this far, we can even say the points that are straight above each other. Also, you'll notice the same numbers coming up in those. It's just a matter of the positives and negatives. So there's all sorts of patterns and symmetry within this picture that we're going to be making use of. Because we're also going to see those patterns and symmetry showing up as we make graphs. And that's our next thing, is we're actually going to be graphing y equals cosine of x. Now, in order to graph cosine of x here, we're actually going to be using that unit circle picture that you just made. Because that unit circle picture is full of points that we can plot. For instance, the very first set of numbers that we found on there, for 0 degrees, what is the cosine of 0 degrees? Well, we can look at the points that you wrote down. Reminder here, cosine, is that the x or the y?
X.
It's the x, yeah. So that means it's the first coordinate that you wrote down for that point. So at 0 degrees, what was the first coordinate you wrote down?
1.
It was 1. And so I can now plot the point 0, 1. So go ahead and plot that point. And as you're doing so, one thing to point out here, I haven't written any scale on my y-axis here. If we do not write the scale on, then we assume that we're going up by ones. However, realize we don't have to go by ones. I could have just as easily chosen to make the top of this be 1 for these examples that we're doing. It's just a choice that we make along the way. In fact, that's going to come up a lot in tonight's assignment. But for now, I just chose to make each line be 1, so we don't have to worry about changing the scale or anything along the way. All right, next point. I'm going to skip the decimals for the moment. Let's go to 90 degrees next. So off of your unit circle, at 90 degrees, what is cosine?
0.
It is 0, because remember, that's the first coordinate, so it's 0. So we plot that point. We go over to 90 degrees, and we go up 0. So notice I'm basically plotting my angle versus my cosine value. My horizontal axis is always my angle, and I'm going up by the amount of cosine. All right, now up to 180. What is the cosine of 180? Remember the coordinates of that point at 180 were negative 1 comma 0. That first coordinate, that is always my cosine. So yes, it is negative 1. So I plot that point. I go over to 180 and I plot it at negative 1. We're just going to keep doing that. 270. What's the cosine of 270? It's 0. Plot it. And then 360. Well, we don't have 360 labeled on our circle. But 360 is the same as what? 0. Because it's gone around one full revolution and ended up back where we started from. And so that point is going to have the same cosine value of 1 as what we started with. Now, when we've done a number of these graphs and gotten used to them, this is all we'll need to be able to draw the curve in. However, this is the first one we're making like this. I want to plot a few more points. I'm going to go ahead and plot those decimals for this first one. If you want to do it on the later ones too, so that you can make sure that your curve is looking good, you can. But on this one, just for your first one, I'm going to actually have you do all of the decimals. So let's go ahead and get those in. So I'm going to put my next point right here. Now that point, what is that angle that I'm at there? Well, if 90 is here, it's got to be like 90 divided by 3, because notice it's been cut up into 3 pieces to get there. 90 divided by 3 is 30 degrees. Okay, so that's going to be 30 degrees. And the cosine of 30, you can take a look at my unit circle. Cosine 30 is 0.87. So that means that I'm going to go over to 30 degrees, and I'm going to get as close as I can to the 0.87. Now, obviously, we're not going to be perfect with plotting 0.87, but we can be pretty close. Then the next one. Let's go ahead and head over to the next. And actually, you know what? There's no line for 45 degrees, which is in our unit circle, but we don't have a line here for it. So I'm just going to go ahead and go to the next line. That means that would be 60 degrees. So let's get cosine of 60 degrees. Cosine of 60 is 0.5. So plot that point. Plot that point at 60 degrees and then 0.5. And having done those, continue going around your unit circle. Plot the rest of the points that will appear over here. Alright, so now this is what your graph should look like once you've plotted all of those other little detail-y points. This then gives us a really nice idea about what the graph is going to look like. So draw the curve that goes through that, and you're going to end up with something that looks like this. Although we still have only filled in the right side of the graph, and we're going to have to see what happens on the left-hand side next. Alright, now for the next one, I need to see what's going on the left-hand side. And this can be a little bit tricky at first, so let's make sure we get the idea. If I think back to the picture of my unit circle, I know that 0 degrees is over here to the right. Negative 90. Negative 90 would mean, the negative means go clockwise 90 degrees. And so negative 90 is straight down. It's the same then as 270. And so then my point is going to go just where I did for 270, which was 0. And we can actually find the other points doing the same thing. Like a negative 180. Well, that's going to be the same as 180. Because if you're going halfway around the circle, it doesn't matter which way you went around to get that half. So that's going to give you the same negative 1. And then hopefully you already see the pattern. But if not, you could continue actually doing the calculations. But there is a nice little pattern here, because it keeps following that same up, down variation. Now, I plotted all the little detail-y points on the right-hand side. I know what the graph should look like now, I hope. And so I'm just going to plot those points at 90 so I know where the top, the middle, and the bottom are. and then draw the curve through those. So this is then what you're looking at for your final graph. Notice basically what's happening here is that our cosine graph on the left-hand side has just repeated itself. And in fact, that's what cosine does, is it just keeps repeating itself. And then to emphasize that idea about how it just keeps on going on forever, if I were to extend this graph past the ends of just our graphing grid, what we'd end up seeing as we zoom out is we'd see that this wave truly just keeps on going on forever and ever, because all of these cosine values come from going around the circle over and over and over again. And I can go around that circle as many times as I want and end up getting the same values, the same x and y coordinates, no matter how many times we want to go around it.